All right, so this is Math 2, Lesson 933, piecewise defined functions. So piecewise functions can seem very scary. So you can see an example of a piecewise function here, and then an example of another piecewise function here. Piecewise functions just means that it's one kind of a function for a little while and another function takes over. And we can do 2 or more functions. We can do 17 functions at once, all sorts of things. This one right here is known as the step function. It's important that you know its name. This is called a step function. It's important that we know what it is and how to use it. So this is a step function. Step functions are exceedingly common when one thing is continuous and the other is discrete, which we will be defining in just a little while. Okay, so continuous means no gaps and discrete means broken up. Like money is discrete by nature. I can have a penny, but I can never have half a penny or a third of a penny or anything like that. So money is discrete, whereas time, I can have half a minute, half a second, half an hour. Time is infinitely continuous. There's all sorts of things. So that's where step functions come from. In this situation, a phone company offers a basic phone plan where they pay a monthly fee of $40. But they must pay extra if their calls exceed the maximum number of minutes. How often do they change their rates? So when it says describe the plan in detail, we have a $40 flat fee for the first 450 minutes. After 450 minutes, they must pay $1.50. It looks like 50 cents for each additional minute. Its domain is the time, and so I would say it's from 0 to infinity. That's the domain. Because if you spend no time using your phone, you're paying $40. If you spend I don't know, say 1,000 minutes, that's still in the domain, and 3,000 minutes is still in the domain, and so on. And granted, you have whatever the month amount of minutes is your actual, so number of available minutes a month. The range, however, is 40, 40.5, 41, 41.5, 42, 42.5, and so on. Okay. Does a graph represent a function? Absolutely. They never charge you two different numbers for the same amount of time. So it is a function, yes. But this is called a step function. We're going to leave it with this information. Our piecewise function, 2 or more pieces. So let's take a look at some examples of piecewise functions. Okay. To draw a complete graph of the following piecewise functions, it may help to make a table first. The first thing that these should both be equal to y. So let's imagine that's there. So I've got y equals 3. Y equals 3 is a horizontal line. This goes from -4 to -2. So -4 is 3. The endpoints are included to 2. Y is 3. Then at 2, another function, -2, another function takes over and goes from and that's 1, -1, and goes from -2 to +2. +2 is included, -2 is not. Okay. Then 5 takes over after that. At 2, 5 takes over. And it goes to 5, which is right about there. And there's my piecewise graph. Pretty straightforward. It gets a little bit more complicated when it's something like this. So what I need to know is when I plug in the endpoint, what do I get? So when I plug in 1, I get 2 times 1 minus 5, which is -3. So 1, -3 is where this one stops. It has a slope of 2. And so that's what it looks like. Then this one starts when I plug in 1. When I plug in 1, I get negative 2 squared plus 1, which is 4 plus 1, or 5. So when I plug in 1, I get 5. That's an open circle, though. And the open closed circle is really important because this one takes over for that one. Okay. Then it's a parabola with a vertex of 3, 1. And so it looks like this. And there's my graph. Okay. So again, that quick sketch stuff that we were practicing, really, really important here. And so that's what a piecewise function is. And it's usually written like this, with the curly brace on one side and either f of x or y out front, or g of x or whatever. And that's the idea. Let's go ahead and define some words. Continuous and discrete. Continuous, just this continuous for this course when points on our graph are connected, and it makes sense to connect them, the graph is continuous. So when they're connected and it makes sense, a continuous graph will have no holes or breaks in it. This term will be more completely defined when you get to calculus, a later course. Discrete, a graph consists of entirely separated points, is called a discrete graph. For example, it's shown below. Okay, so this is discrete. Scatter plots are discrete. Discrete graphs are graphs that are not connected in any way. So this graph is neither continuous or discrete. It has a discontinuity, but the rest is continuous. So it's discontinuous right there because of the jumps in the graphs, but the other pieces are continuous. Okay. Are there any questions about that basic idea? Okay. Let's take a look at this next situation. Elisa is training to run a 5-mile fun run. She runs from her house to her friend's house 2 miles away. She talks to her for 10 minutes while she stretches, and then she runs home. So this is a little weird, but she runs, and I don't love this graph for this. She runs, she talks, and she runs home. So before we continue to be discrete or continuous, we've got time, which means it's continuous. And she's there. So I'm going to say this is a continuous graph and see what you can make of it. Okay. If you just try to draw me a picture, don't try to write the equation. And that's all. That's where we're going to stop for today. I hope this was enjoyable for you. I will see you guys soon.